a more formal look at the background of the simplex method and what makes it work. Starting with our linear problem that we want to optimize. A is going to be of full rank so that I can solve for my basic variables. Rearrange my indices into two groups. The basic variables, all the indices are put into B, and the non-basic variables, all the indices are put into N. Rewriting the constraint in this new notation. And rewriting the objective function. Putting this back into the problem. And solving for the basic variables. A sub B inverse exists because A is of full rank. Substituting our basic variables back into our objective function and distributing. The objective function is now entirely dependent on the non-basic variables. Terminology: a basic solution is defined as the non-basic variables are set to 0. A basic feasible solution is when the basic variables are feasible. For a basic solution, there's our criteria for basic feasible solution. Write the dependence on x sub n more explicitly. That row vector applied to x sub n. Any index where the component is positive means the corresponding component in x sub n can be made positive to increase z. Put that index into the basic set. Then we need to find an index in the basic set to go into the non-basic set. The criteria is to maintain feasibility. So there's step 1 and step 2 of the simplex method. Optimality is if this row vector has only negative components, non-positive components. The maximum for z is then when x sub n is 0. A basic solution. basic feasible by step 2. Putting it in the tableau, we can always reorder the columns in the tableau. Solving for the basic variables. X of n multiplies this row vector in the objective function with toggled sign. Our feasibility and our function value for the basic solution with toggled sign. There's only 2 conditions then for the simplex method to work. A is of full rank and feasibility is maintained.